Hello guys, welcome back to the channel Engineer Study, where we are learning the various microcontroller. In last video, we start 8051 microcontroller with theoretical part. Now we start the programming part of it. So in today's video, we are going through addressing modes of 8051. But before starting the addressing mode, we should know some basic terms which are useful in programming. Now let's start. Firstly, we should know data size. The microcontroller operation is always performed on a bit. So what is bit? Bit is a binary digit that can have the value of 0 or 1. It is single 1 or single 0. Next, byte. Byte is a combination of 8 bits, and the combination of 4 bits is known as nibble, and the combination of 16 bits is known as word. Flip-flop is a 1-bit storage device. That means the device which is used to store 1-bit data is known as flip-flop. This is the D flip-flop, and the combination of flip-flops is known as register. It is used to store 2 or more bits. This is the 4-bit flip-flop, and it can be represented as like this. As I told you, we are moving towards the program. So, what is the program? Program is a set of instructions which is used to perform any specific task. This is the program. It is the set of instructions. Now, what is the instruction? Instruction is a command that a particular processor understands and executes. It is made up of opcode plus operand. Now, what is opcode and operand? Opcode is a command, that means it is an operation which has to be performed, and operand is a data on which the operation has to be performed. See the example, move a, r1. Here, move is the opcode and a, r1 is the operand. See, on the left side, destination is present, and on the right side, source is present. Data is always transferred from source to destination like this. Now the assembly language. It is referred to as a low-level language. As we know, English is a high-level language, but computer controller doesn't understand this English language. It understands low-level binary language. So, assembly language is developed which is in binary form. An assembly language program consists of a series of lines of assembly language instructions. It includes a mnemonics. Mnemonics means a command to the CPU or controller. It is optionally followed by 2 or more operands, that data items being manipulated. In 8051, there are 1 byte, 2 byte or 3 byte instructions are present. It depends on the operand size, cause operand may be have 8-bit data, 16-bit data or 0-bit data for the operation. And the opcode is always 8-bit long. Now we are moving towards the main part of this video, that is addressing mode. What is the addressing mode? It is the methods of specifying the data to be operated by the instructions. Data could be in register, memory, ports, or it may be immediate value. So addressing mode is the way of microcontroller to access the data or operand from internal memory, external memory, registers, or directly it may be immediate value. Means what? For performing operation, microcontroller require the data. That data may be stored at anywhere, means in memory, registers, ports, anywhere. So how can microcontroller access this data? That is the main thing. So data accessing methods means addressing mode. Remember this line always. Data accessing methods means addressing mode. By using the efficient modes of addressing, will increase the processing speed of CPU or controller. Now the types of addressing modes in 8051. First is immediate addressing mode. Second is register addressing mode. Third is direct addressing mode. Fourth is register indirect addressing mode. Fifth is indexed addressing mode. Sixth is bit addressing mode. And last, absolute addressing mode. These are the 7 addressing modes in 8051 microcontroller. Now, first, immediate addressing mode. In this, the data on which the operation has to be performed is directly given in the instructions. See the example, move R1, hash 05H. In immediate, hash is represent the immediate data. Okay. Now, hash 05H is the immediate data which can be transferred directly into the R1. Means in immediate addressing mode, data is given directly in the instruction, so immediate operation can perform. That's why it's called immediate addressing mode. This mode of addressing uses either an 8 or 16-bit constant value as the source operand. This constant is specified in the instruction rather than in register or memory location. The destination register should hold the same data size which specified by the source operand. That means what? The size of the source should be same as the destination register. See, add A, hash 03H. Here 03H is the 8-bit data and accumulator is the 8-bit register. So this is the valid instruction. Move R1, hash 05H. In this, 05H is the 8-bit data and register R1 is also the 8-bit register. So this is the valid instruction. But move DPTR, hash 08H is the invalid instruction, cause hash 08 is the 8-bit data and DPTR is the 16-bit register. That's why it is the invalid instruction. Let's see the operation of immediate addressing mode by this example. Move A, hash 15H. Here hash 15H is the immediate data which is directly transferred into the accumulator. After executing this instruction, the content of accumulator is 15H. The next is register addressing mode. When in instruction, the name of the register is directly given where the data is available, then it is the register addressing mode. For example, move A, R0. The operand for an instruction is located in one of the 8 general purpose register R0 to R7 or accumulator. These registers are directly accessible and offers fast data manipulation. Source and destination register should be same size. See, move R2, A. Here accumulator and register R2 both are 8-bit register. In add A, R5, accumulator and register R5 both are of 8-bit register. That's why these are the valid instruction. But move R5, DPTR, this is the invalid instruction cause DPTR is a 16-bit register and R5 is the 8-bit register. Let's see the operation of register addressing mode with example. Move A, R5, that means transfer the content of R5 to the accumulator. See, the content of R5 is the 79H which is directly transferred into the accumulator. After executing this instruction, the content of accumulator is become 79H. The next is direct addressing mode, in which address of the data is directly given in the instruction. Direct addressing mode allows accessing the data from internal RAM of the 8051 microcontroller. The operand specifies a memory location directly, allowing efficient access to variables and data arrays. See the example, move A, 60H, that means transfer the content of RAM location 60H to the accumulator. These are the memory locations with data. Microcontroller goes on the memory location 60H and find out the contents of it and transfer these contents into the accumulator. After executing this instruction, the content of accumulator is become 10H. See the next example. Move 20H, 40H. Here, transfer the contents of address 40H to the address 20H. The next example is move 50H, A. Here, transfer the contents of accumulator to the address 50H. Remember now one thing, if in instruction, if only number is present, then it is the direct addressing mode. But if number is followed by hash, then it is the immediate addressing mode. The fourth addressing mode is register indirect addressing mode. Means address of register is directly not specified in instruction, it gives through registers. Microcontroller accessing the memory locations indirectly through a register pair. Only registers R0, R1 and DPTR can be used as pointer register. R0 and R1 registers can hold 8-bit address, whereas DPTR can hold 16-bit address. DPTR is useful in accessing the operands which are in the external memory. Now see the operation of register indirect addressing mode with example. Move @R0, A. That means store the content of accumulator into the memory location pointed by the contents of register R0. R0 could have an 8-bit address such as 72H. Let's see, R0 contains is 72H and the content of accumulator is 12H. Now, the content of accumulator is transferred into the memory location which is stored in the R0. After executing this instruction, the content of memory location 72H is 12H. Now, let's take another example. Move A,@R1. That means R1 stores the 8-bit address on which the data is present and this data is transferred to the accumulator. Now see the content of R1 is 60H. Microcontroller goes on this 60H memory location and transfer the contents of 60H to the accumulator. Now the content of accumulator is 10H. Let's see the another example for 16-bit address. Move A,@DPTR. That means transfer the contents from the memory location pointed by the DPTR into the accumulator. See, DPTR is a 16-bit register. That means it holds a 16-bit address such as 1243H. The content of DPTR is 1243H. Now, microcontroller goes on this location, find out the contents and transfer it into the accumulator. Now, the content of accumulator is 40H. Listen, register addressing mode is identified by @ sign. The fifth is indexed addressing mode, which is very confusing, and it is also known as relative addressing mode. Here, accessing the memory locations by adding an offset to a base address. The offset usually stored in one of the 8-bit register, that is accumulator or register R0 to R7, and 16-bit register, that means data pointer or program counter used to hold the base address. And the sum of these two registers forms the effective address for a jump or move C instruction. Let's see the operation with example. Move C A, @A plus DPTR. That means the addition of content of accumulator and DPTR forms an address on which the contents are present and that contents transfer to the accumulator. See, the contents of accumulator is 10H and the DPTR contents are 1600H. Now perform the addition of these two registers, 10H plus 1600H. Now the effective address is 1610H. Now microcontroller goes to this memory location, that is 1610H, and find out the contents, and that contents is transferred into the accumulator. See, firstly the content of accumulator is 10H, but after executing this instruction, the content of accumulator is become F1H. Sixth is bit addressing mode. Bit addressing mode is specifically designed to manipulate individual bits within the SFR. SFRs are a set of memory mapped hardware registers used for controlling various on-chip peripherals. This mode allows reading or modifying specific bits within this register. C. Actually bit addressing mode is used to perform the operation on a single bit, like this. Set B port 1.2. That's mean what? Set the bit 2 of port 1. Here mainly set or reset operation is performed. Last is the absolute addressing mode. Absolute addressing mode is a specialized mode used for accessing specific memory location in the external RAM or code memory space. It requires a 16-bit address to identify the memory location, it allowing direct access to external memory and code memory. Absolute addressing mode addressing within the 8051 is used only by the AJMP and ACALL instruction. That means absolute jump and absolute call instructions. All addressing modes with the examples are listed here. The examples of immediate addressing mode is MOV A,#05H. The example of register addressing mode is MOV A,R1. For direct addressing mode is MOV A,12H. For register indirect addressing mode, MOV A,@05H. For index addressing mode is MOV A,@A plus DPTR. For bit addressing mode, set B port 1.5. For absolute addressing mode, ACALL and AJump instructions are used. This is all about the addressing mode. In next video, we will see instruction set for programming. If you like this video, please share, subscribe and like it. Thank you for watching.